the 1 gigabit per second link and also 100 megabit per second link. And let me to write here, when we have switch 1 and then switch 2 and then switch 3. Okay, now the switch 2 is the root bridge. We should compare all of the for example conditions with each other, and you know that now the link between the switch 1 and switch 2 is active, and also the link between the switch for example 2 and switch 3 is active. Let me to show you. This is the next link, and the bandwidth of this link is 1 gigabit per second, and the bandwidth of this link is 100 megabit per second. It's okay. But if the switch 3 is the root bridge, okay, the result is the link between the switch 3 and switch 1 now is active, and also the direct link between the switch 3 and switch 2. As you can see, we are using 2 fast Ethernet or 200 megabit per second link. Let me to show you the next condition: switch 2, again switch 3, and then for example switch 1. In this scenario, we are using the switch 3 as the root bridge, okay, not switch 2. And then the active links include the direct link between the switch 1 and switch 3, and also switch 2 and switch 3. As you can see here, we are using only the 100 megabit per second link, not the gigabit per second. And as you can see, this is not good condition. Why? Because we don't use the 1 gigabit per second link or with the link with the higher bandwidth, but we are using the links with the lower bandwidth. And you know that for primary links we want to use the more bandwidth, and for secondary we can use less bandwidth. For example, in this example, when we have the switch 1 as the root bridge, we are using 1 gigabit per second. If the 1 gigabit per second link fails, we can use 100 megabit per second between the switch 2 and switch 3. In most cases, and maybe in all cases, we should use the link with more bandwidth with the as a primary link, and the links with the less bandwidth for the secondary link. And this is obvious that we should do with this for example manner. After that, now we can understand that the place of root bridge is important for us. If you select the root bridge, you will learn about the selection of root bridge rules. If you select the root bridge in one bad place, for example in this example in the switch 3, you will use the lower bandwidth as the primary link, and you will use the, for example, more bandwidth as the secondary link or as backup link, and this is not good. Because of that, now we can understand the place of root bridge is so important for the active topology. This is the active topology, okay? And now in the for example high level view of the STP, we can understand that how STP is working overall. First, a root bridge is electing. After that, we can go from the root bridge to the other switch with the best bandwidth that is available. And now we can understand that the place of the root bridge is so important. Placement of the root bridge is so important. We will learn about the detail of the root bridge selection, and after that how we can place the root bridge in a good place. Okay, let me to talk about a little more about the function of the STP. You know that until now we talked with high level view, and now I'm going to give you more information. I assume that this is the medium level view. Okay, in medium level view we will learn more than this, but also after medium level we will talk with more detail. We call it low level. Now I'm going to talk about the STP and its function with medium level. Okay, starting the medium level to finding how STP is working, let me to remove the high level view information. Very good. How STP is working, starting from the scratch. You know that in STP we are trying to converting a not spanning tree or non-spanning tree network to a spanning tree networks. You know it, okay? How? In STP we have 3 steps to converting the non-spanning tree to a spanning tree networks. The first step is electing the root bridge. Elect root bridge. I know that in the for example high level view we talked about the electing root bridge, but now I'm going to give you more information that how root bridge is electing. Let me write here, electing root bridge. This is the first step. and I will talk about the detail of this. The second step is selecting the root ports. You will learn about these steps with more detail. Let me write here root ports. And after that, the third step is selecting the designated ports. Okay, what is the root port? What is the designated port? We will talk about them. Let me start talking about the STP with the first step, electing the root bridge. How we are electing the root bridge, and this is real. This is exactly the, for example, function of the STP. For electing the root bridge, we need to talk about first some fundamental topics about the switch, and after that we can talk about the electing root bridge. Electing root bridge. Each switch in STP has an identifier. Okay, for example, this switch has one identifier, this switch has another identifier, and also the switch tree also has another identifier. We call it bridge ID. You can say switch ID. Bridge ID or switch ID, both of them are same. Let me write here. Each switch has an identifier in STP. We call it bridge ID or switch ID, or maybe STP bridge ID or STP switch ID. All of them are same, okay? But what is the bridge ID or BID? Here we have one formula for the bridge ID. The first part of the bridge ID definition is bridge priority. You will learn about it, don't worry. Bridge priority. And after that, we colon MAC address, okay? You know the MAC address. And this is the bridge ID. Bridge ID include bridge priority or STP bridge priority, then MAC. STP bridge priority or bridge priority has 16, okay, bits length, okay, means 2 bytes. After that, we can say the bridge priority is a number between 0 to 65,000, okay, 535, and the default value is 32,768. This is the default. Because of that, the bridge ID of the switch 1, now the bridge ID of switch 1 is 32,768 colon MAC of switch 1. In each switch, we have one MAC address for the protocols, for example, for STP or some other protocols. Because of that, you know that the MAC address is unique. Because of that, the bridge ID is unique. This is the bridge ID of the switch 1. And also we call it BID1. BID1 means bridge ID of the switch 1. After that, we have bridge ID of the switch 2 equal to, again, the same priority, and then MAC 2. And after that, BID3. We have 32,000 again 768, then MAC 3. Here you can see 3 BIDs. Each switch has one BID. You know that the STP now is available in all of these switches, okay? Because STP is installed in the, for example, the iOS. We have the STP in all switches, and now each switch has one BID. You know it, okay? The BID of switch 1 is 32,768 colon MAC 1. I will show you this bridge ID, okay? BID 1, and then BID 2 here, and finally BID 3. Okay, now you learn about the BID. You know that the MAC address is unique. Because of that, we can say each BID is unique, and the BID 1 cannot be equal with BID 3 or BID 2. Okay, now let me to talk about how we are selecting or electing the root bridge. Here we have a rule, okay? This is a rule of the STP. In STP, the root bridge is the switch or is the bridge with the lowest bridge ID. Lowest STP bridge ID. Each switch has one bridge ID, and the bridge IDs are not equal, cannot be equal, because in bridge ID we are using the MAC address, and the lowest bridge ID is the root bridge. Okay, let me to show you. Here, for example, in this example, you can see BID1, BID2, and BID3. Assume that, let me to give you one example. Assume that MAC1, okay, is lower than MAC2 and is lower than the MAC3. For example, this is the MAC1. MAC1 is quad 0, quad 0, 0, 0, 1, and the MAC2 is quad 0, quad 0, 0, 0, 2, and MAC 3 is quad 0 quad 0 0 0 3. Okay, 0 0 0 3. And as you can see, the MAC 1 is